This video will be about simplifying radicals and radical expressions. So in order to do this, radical, don't forget, is just a square root of some number or variable. Doesn't really matter. Could be both. But in order to do this, we really need to understand prime factorization. So say I want to find the prime factorization of like 28. I know that I can find 2 and 14 because 2 times 14 is 28. 2 is my prime number, so I'm going to put it on the left. From 14, I know 2 times 7. 2 is also a prime number. Put the small one on the left. 2 times 7. 7 is also a prime number. So the prime factorization of 28 is 2 times 2 times 7, which is just 2 squared times 7. Another example, if I want to do the prime factorization of 20, I have 2 and 10. 2 is the prime. 10 goes to 2 and 5. So I know prime factorization of 20 is 2 squared times 5. Notice I have kind of a pair of 2's here and a pair of 2's here. Doesn't always have to be a pair of 2's though. Could be like, say I wanted to find 27. I have 3, and this is 9. 3 times 9 will give me 27. 9 will break down even further into 3 and 3. So this one will actually be 3 cubed. 3 times 3 times 3 will give us 27. These are all the prime numbers, so these are kind of what I really want to look at. Just like up here, 2 times 2 times 7 is what I really want to see. 2 times 2 times 5 is really what I want to look at. This is going to help us with our square roots. Don't forget, after these few examples, try to start doing these by yourself. Try to pause the video and actually start doing it. So for this first one over here on the left, the square root of 125, I don't know it. But we can look at our prime factorization of 25, what we just talked about. I know 5 times 25 will give me 125, and I can break down 25 even further into 5 and 5. Now I'm taking the square root, because 125, I know this is 5 cubed, and I want to find the square root of 125, so I'm finding the square root of 5 cubed. Well, here's a pair. So what I'm going to do is take out this pair. I'm taking out a pair of 5's, so I'm going to put a single 5, indicating that I'm taking out a pair of 5's, and still inside I have whatever's left over in my factor tree, which is 5. That's your final answer. Square root of 125 is 5 root 5. So over on this case, what we're going to do first is kind of do our prime factorization of 216. I know 2 divided by 216 is 108. I can split up 108 into 2 times 54. I can split up 54 into 2 times 27. I can split up 27 into 3 times 9. Sometimes they're long. Split up 9 into 3 times 3. Well, I have a pair of 2's and I have a pair of 3's. So I can pull out a 3 and I can pull out a 2 from that. Now I'm pulling out multiple things. So when you pull out multiple things, you're going to have to multiply them together. So 2 times 3 is 6 on the outside, and on the inside you have whatever's left over on your prime factors. You have a 2 and a 3 left inside, so same thing, when you pull them out you multiply. If you leave them in, you multiply whatever's left over. So you're left with 6 on the inside. Can't really do anything with this v because it's only a single v, so it's going to stay inside as well. Again, this is probably the point where you can try to start trying to figure these out if you can. If not, that's okay. Just keep trying. So with these, look at your number first, and then you can look at your variable. So try to do the prime factors of 512. Well, that might take a while, who knows. So with 512 we have 2 and 256. 256 I have 2 and 128. With that I have 2 and 64. With 64 I have 2 and 32. This will give me 2 and 16. 16 is 2 and 8. 8 is 2 and 4. This looks like a lot of 2's. 4 is 2 and 2. So I have 1 pair, 2 pair, 3 pair, 4. So this is like I'm pulling out 2 to the 4th power. So I have 4 pairs of 2's. So 2 to the fourth is 2 times 2 is 4, times another is 8, times another is 16. So I'm pulling out 16 for my number. Now look at your variable. It's on the inside, sorry. I'm going to be left with whatever's left over here. So right there. Now look at our variable. So with the square root of k squared, just like I pulled out 2 to the fourth, k squared, there's a pair of k's. K squared is like saying k times k. If you want to look at your factor tree, k, beautiful k, times k, that's a pair of k's. So you can pull out a single k, so you have a single pair of k's. This would be your final answer. If you want to make it look pretty, then write better than me, but you can make it smaller. Okay? With this one, we have square root of 100v cubed. Do I know the square root of 100? Yeah, it's 10. So I can just pull out a 10. With v cubed, this is like saying v squared times v. So I have a single pair of v's that I can pull out. What's left is whatever's left on the inside. It's just our v. There's your solution. These are the last two I'm going to do for this video, so go ahead and try and give these a shot yourself. So with 80p cubed, look at your 80 first. Do your tree here. We have 2 and 40. 40 will give us 2 and 20. 20 will give us 2 and 10. 10 will give us 2 and 5. So there's all our prime numbers. So I have one pair of 2's, two pair of 2's. So I'm pulling out 2 squared. Multiply them together, so I'm pulling out 4. On the inside, you're still left with your 5. Now look at your p's. P cubed is like saying p squared times p. So I have a single pair of p's that I can pull out, and I'm left with 1 p on the inside. That will be your final answer for there. With this one, break down 200 first. Always look at your number first. So that's 2 and 100. Well, I can break this down into 2 and 50, but notice, I already know the square root of 100, so I can make a pair of 10s. So that way I don't have to do all this multiplying to pull out the 4. I can just pull out a pair of 10s, so that will have a 10 on the outside. M to the fourth, well that's m to the fourth is like saying m squared times m squared. So I have 2 pairs of m's, so I will show 2 pairs of m's. There's only a single n, so that will stay on the inside. I was left with a 2 on my tree, so 2, n will stay inside. There's your solution.